All right.
First, we got to note that the figure is not drawn to scale.
Okay.
All right. Steve and his friend are playing together on a seesaw.
Who's his friend?
Trace and Yamil are playing on the seesaw together, shown in the figure above. As time t equals 0 seconds, the distance between the top of Yamil's head and the ground is 24 inches. At his highest point, Yamil's head is 60 inches above the ground. Steve goes all the way up and back down on the seesaw every 3 seconds. As the two friends, Yamil and Trace, play on the seesaw, the distance between the top of Yamil's head and the ground periodically increases and decreases.
Love that. Love that. So let's break it down. How long does it take for Yamil's head to go up and then down? 3 seconds. So that's its period. So its period is 3 seconds. Now, where is the lowest point of Yamil's head? How far off the ground is the lowest point of Yamil's head? 24 inches. All right. How high is the maximum of Yamil's head? 60 inches. All right. Pretty good. Cool. Now, is Yamil's head starting at its maximum? So is point F the starting point? No, because Yamil's head starts at 24, right? And so we need to get up to the top. Well, how long is it going to take to get up to the top? 1.5 seconds. Why is it 1.5 seconds?
It takes the whole thing as 3 seconds.
Because it takes 3 seconds to go up and then down. So F has a t value of what?
1.5.
1.5, comma. How high is he?
60.
60. All right. Now, Campbell yesterday was like, yo, let's do point P next. And I kind of like it that way. And so point P is a full period. And so what is my time to get to the next time Yamil's head goes all the way up?
4.5.
4.5. And Yamil's head is still at what? 60. Love that. All right, so now I like to go to the bottom. Now, what is the time in which it takes Yamil's head to get back to the bottom?
1.5. Well, now it's 3 seconds.
Now it's 3 seconds, exactly. All right, and so it's 1.5 more than that. And so this would be 3 seconds. And then how high is Yamil's head? 24 inches. Love it. All right. And so to get to G and K, we need to kind of take an average of those two. And so we need 1.5 and 3. So what's in the middle of 1.5 and 3? 2.25. All right. And this is without a calculator, guys. All right. So 2.25. And then what is the middle of my little seesaw? So 60 and 24. What's the average of them? 42. All right. So I personally add them together to get 84. Divide by 2, we get 42. And so then K, what's my point K now? 3.75, comma what? 42. Love that. All right. Pretty good. So it still made our sinusoidal curve right there. All right. Part B.
Refer to the graph of D in part A. The t-coordinate of F is t of 1, and the t-coordinate of G is t sub 2. Is that what it is?
Yeah.
All right, J, on the interval of t sub 1 and t sub 2, which of the following is true about D?
All right. So is D positive or negative? So I'm looking at my Y values. Are my Y values positive or negative? They're positive still, all right? And because it's a distance, they're going to be positive. And so then, is this increasing or decreasing?
Decreasing.
It's decreasing. Why is it decreasing? No, it has nothing to do with concavity. It's decreasing because why? It's going down, all right? And so it's positive and decreasing on this one, all right? And then part number 2 of B.
Describe how the rate of change of D is changing over the interval of t sub 1 to t sub 2.
Now, Ethan, tell me why. Good. So D is concave down. So the rate of change of D is what? Decreasing.
A prize wheel is used for a game show that has an electronic motor that allows a circular wheel to spin at a constant speed in the clockwise direction until a contestant presses the stop button. The center of the wheel is 30 inches away from point A. At time t equals 0 seconds, point A is the lowest spot on the wheel. The distance between point A and level table is 15 inches as shown in the figure. The wheel completes 4 rotations every second.
Ooh, that's
As
fast.
the wheel spins, the distance between point A and the level table periodically increases and decreases. The periodic function d models the distance in inches between the point A.
All right, let's stop there. Let's stop there. All right. So it says the wheel completes 4 rotations every second. So what's my period on this one?
0.25.
0.25, exactly. So my period is what? 0.25. All right, so my period is 0.25. All right, so we're going to kind of like store that in the back. What is my lowest point it can be at? What is my minimum going to be at? 15. All right, because I'm 15 above the level of the table. So my lowest is going to be 15. What is the highest point this wheel is going to be at?
30.
It's not 30. It's what? The center of the wheel is 30 inches away from point A.
60.
So what? All right, let's try this. So this is 15, right? And then the radius is 30. So how do I get to this other part? Another 30, right? And so what's the highest point on this wheel? 75. All right, first try. That was good. All right, so now is my wheel starting at the maximum? Like my graph. My graph shows that it's starting at a maximum. Is my wheel starting at a maximum, though? No. And so how long is it going to take to get to the top? 0.25 divided by 2. All right, so what is 0.5 divided by 2? 0.25 divided by 2. So we got 0.125. All right, and then how high is my wheel? 75. All right. So then let's go with Campbell's method again. And so I'm going to get to point P now. And so what do I need to do to get to point P?
Full rotation.
A full rotation. So I need to add how much to it?
0.25.
0.25 to it. And so now we're at what?
0.375.
0.375. And then I'm still at what?
75.
75. All right. So now I'm going to go to J. I'm going to go to J next. And so what is the lowest I'm going to get to? 15, right? And so when is that going to happen? What time period is that going to happen in? It starts at the bottom and then it has to go all the way around. And so 0.25, comma, 15. Okay? And then this is the hard part. So now we have to be like, okay, we have to figure out the middle of 0.125 and 0.25. All right? And so we have to figure out what's in the middle of that. Now, there's multiple ways to tampa, and I'm going to kind of talk about 2 ways, and then we'll figure out which way we want to go. So you could add them and divide by 2. Is that a good method? Let's do it. Let's do it. All right, and so let's add them together. When we add them together, what will we get? 0.375. So we're going to take 0.375, and we're going to divide it by 2. So how many times does 2 go into 3? 1, and then we multiply, so now we get 2. And so then we subtract, or we add a negative, and then we get 1, and then we drop it like it's hot, and so then we get 7. And then what do we do? 2 into 17 goes in how many times? 8. And so now we multiply, so we get 16, and then we subtract, or we add a negative, and then we get what? 1, and then we drop our 5. And so then how many times does 2 go into 15? 7, and then we get 14, and then we subtract, and then we get 1, and then we drop it like it's hot, and then we get 0, and so then we get what? 5. Okay? And so if you didn't know how to do it, we can always go off to the side and go old school. All right? And so G is what? 0.1875, comma. Now, what's in the middle of 75 and 15? 40. No, not 45, but yeah, 45. I'm sorry, 45. Yeah, sorry, 45. All right. Another way to think about it is it's 15 up and then 30 more, so it's 15. All right. And so then to get to K, again, there's lots of ways to tampa on this, but there's a couple methods that you could use. And so, do you see how like this is So one method we can use is like if you subtract these two and then add it to 0.25 instead of like adding these two and dividing by 2, you can kind of do it that way. All right. And so if I do 0.875 minus 0.125, then we'd end up with what? So this would be a 5, right? And then what? 2, and then 6, and then 0. So the difference is 0.0625, right? And so then we would add 0.25 to that. So we would add the 0.25 to that amount. And so then I'd end up with a 5 and a 2, and then we'd carry a 1, and then we'd get a 0.3125. All right, so I had to do a little bit of algebra with you, or technically just arithmetic. All right, stuff you've been doing since 6th grade. All right, and so now we have that as my x value or my t value. And again, what's the y value? What's the height? 45. Go.
Can we go to D?
Yeah.
Refer to the graph of D in part A. The t coordinate of J is T1.
T sub 1, yep.
T sub 1, and the t coordinate of K is T sub 2. On the interval T sub 1, T sub 2, which of the following is true about D?
All right, so is D positive or negative? Positive, because they're all y values are positive. All right, and is it increasing or decreasing? Increasing, because why? It's going up. All right, and so which one says that? A. All right, and then part 2 now.
Describe how the rate of change of D is changed over the interval.
All right, so D is what? Concave up. D is concave up. So the rate of change of D is what? Increasing.